Okay, good morning everyone. How are you all? Hope you all are good and fine. Okay, so today's our topic is quadrilateral. In last class we studied about the introduction and some examples and questions. Today we are doing very important question regarding of this quadrilateral. So let's do it. So this is your chapter number 8, quadrilateral. Okay, so there are some different types of question. Among that, one is very important, and that is, if you have a parallelogram, we can give any name like A, B, C, D. Okay, A, B, C, D is what? It is a parallelogram. And if you join B to D, you know what is B and D? BD is a diagonal, right? And there are 2 points on the diagonal. One is P and the second is Q. Okay, now when we join this P to A and C to Q, as well as A to Q and P to C, then there is a certain figure comes APCQ. So can you tell me what is APCQ? Okay, I will tell you. This APCQ will be a parallelogram. Okay, and you can prove it how this APCQ is a parallelogram. So that is our question also. So let's prove that APCQ is a parallelogram. Okay, this is the sign of parallel and GM means gram, parallelogram. Okay, so if we need to prove this figure APCQ is a parallelogram, but in the question the given statement is that the outer quadrilateral ADCB is a parallelogram. So how we prove that the inner quadrilateral APCQ is a parallelogram? So for that reason, first of all you have to prove these things also. What? Prove that AQ is equals to CP. Then also you need to prove that the triangle ABQ is congruent to triangle CDP. Okay, then the fourth thing is prove that AP is also equals to CQ, and that also prove APD, triangle APD is congruent to triangle CQB. So that much we have to prove in this figure if we need to prove that APCQ is a parallelogram. Okay, so for that reason we have to prove these 4 along with this first one. Okay, if you need to find only this one, then you have to go through all these 4 statements, right? So for that, first of all we need to prove this one. We will go reverse, then we will reach at our point that ABCQ is a parallelogram, right? Okay, so the first thing which we are going to do here is we need to find the last point first, which is the E1. What is that? Prove that this triangle ADP is congruent to CQB. Triangle number 1 is congruent to triangle number 2. Okay, so how to prove it? Let's see. In the given question, what is the question? Question is that ADCB, or you can write it ABCD, is a parallelogram in which PD is equals to QB. PD is equals to QB or BQ. Okay, so that much is given in the question. So the first thing which we can write is what are the given statement, and the given statement is only that the triangle ABCD is a parallelogram, as we can see in the questions. And secondly, it is given that PD is equals to QB. Okay, now what we need to prove here, you can write it, all these we need to prove it here. So how to prove? So for that reason you can write it, to prove. These are the statement which we can write it here, to prove. And what are the proof statement? So here we write what we need to prove here. Okay, let me raise it. Alright, so first thing is which we need to prove here, that the triangles are congruent. So we have to write it, the A part is triangle, so we can write that triangle name. In triangle APD and triangle CQ, what is the name of this way, this point? B. Triangle CQB. Okay, so first of all we select these two triangles, and now we can prove that these two triangles are congruent. Can you tell me by which congruency criteria these two triangles are congruent? Yes, as we know that this ABCD is a parallelogram. So if it is a parallelogram, then the opposite sides are equal, obviously. But ABCD is a parallelogram, that is given. It is not given that APCQ is a parallelogram. This is what we need to prove, right? So in this triangle APD and CQB, we have to prove that whether these triangles are also congruent. Okay, so we have the same reasons to prove the fourth or these 5 questions. So we will do it first, the E part, which is these two triangles are congruent or not. Only in this way we can prove that the sides are equal. Okay, so first we will write that in these two triangle, as we know that this side AD is also equals to side BC, isn't it? Tell me why. This component of APD, we can write it AD is equals to this side CB, obviously, because these are the opposite sides of parallelogram, and we know that the opposite sides of a parallelograms are equal, right? So these sides are already equal. Now what you can say about this angle and this angle? Can we say that these two angles are equal? Yes, obviously you can say that. Why? Because we know that this BD is the diagonal, and in the parallelogram we know that if it is parallelogram, if this is a transversal line, then these two angles are equal, because yes, of course they are making Z. That's why if they are making Z, that these two angles are alternate interior angle. Okay, so we can say here that ADP angle ADP is equals to angle, what is the name of this angle? CBQ. Angle CBQ. Why? The reason is same. Look at this Z figure, this angle and this angle. So these are alternate interior angles. All right. So after that we can write it this side DP is also equals to BQ. It is given in the question. So the third component is DP is equals to BQ. Why? Because it is given in the question. So that statement is given. Now can we say that the two triangles are congruent? As we can see here in this triangle, this side equal, this angle equal, and this side DP is equals to this side. So the three components are equal. Therefore we can say that the triangle APD is congruent to triangle CQB. Now can you tell me what is the criteria? Yes, of course, side. Here it is the angle which is in between the side and one more side. So the criteria is by side angle side. Yes, so here we write by side angle side congruency criteria. Okay, so now we prove that these triangles are congruent. Now we can say their corresponding parts are also equal. Yes, of course, by CPCT. So here we are going to take this side which is equals to this side. What is the name of this side? This side AP is the component of the side ADP. So we write it here, AP is equals to CQ. Why we choose this side? Because these sides are the part of the inner quadrilateral, which we need to prove that this is a parallelogram, right? So you have to choose this side. So we can say that these two sides are also equal by CPCT. Of course, you know the meaning of CPCT, corresponding part of congruent triangle. So we prove that these sides are equal. Okay. Now, so if these sides are equal, so we are going to do now the second part, which is, we have already proved it here, that AP is equals to CQ by CPCT. So now we are taking the third point, which is prove that this triangle number 3 is also congruent to triangle number 4. Okay, so now what is the name of this triangle? ABQ, this triangle, and this triangle is CDP. The name of this point is P here, right? So we are choosing this triangle first. So again you can write the same statement in triangle ABQ and triangle CDP. Okay, so in this two triangle, now you can see that because ABCD is a parallelogram, so we can say yes that AB is also equals to CD because it is a parallelogram, and we know that the property of a parallelogram says that the opposite pair of lines are equal. Opposite, both the pairs of lines are equal. That means AD is equals to BC as well as AB is equals to CD, right? So the same statement we can write it here, that in this triangle ABQ, the line segment AB is going to be equal to CD, isn't it? Okay, and the reason is because yes, opposite sides of parallelogram are equal. Okay, now the same thing is here. We can say that in this triangle ABQ, this angle, and in this triangle CDQ, this angle, are these two angles also equal? Yes, by the same way these two angles are situating on either side of the transversal line. That means they are making Z. These are alternate angles. So similarly in this ABDC, they also making Z. So that means this angle is also equals to this one by alternate interior angle. So what is the name of this angle? ABQ. So angle ABQ is equals to angle CDP. And the reason is because they are alternate interior angles. Alright. Now the third component is, we already proved that the side BQ is also equals to DP. Here we return it, DP is equals to BQ. So similarly we can say BQ is equals to DP, right? So BQ is a part of this triangle, so we can write it here, BQ is equals to DP, because it is given in the question. Alright, now the three components are equal, so therefore we can say that the triangle ABQ is congruent to triangle CDP. Okay, so again, what is the criteria? Similar, these are the two sides and the angle is in between the sides. So can we say the same criteria? Yes, by side, angle, side, because the angle is situating between the side, that's why we are using side, angle, side. So you can write the reason by side, angle, side congruency criteria. These two triangles are congruent. Okay, now so if these two triangles are congruent, therefore we can say that the corresponding sides are equal or corresponding angles are equal by CPCT again. So here we can say that this side AQ, as you can see, this side AQ, is this equals to CP? Say yes or no, right? Because this side AQ is the part of ABQ and this side CP is the part of CDP. So we can say that side AQ is also equals to side CP, and that is our fourth point. So here we can write that the fourth point is these are our point A, B, this is Q, join it A to Q. So we already proved that this line is equals to this one, and now we are going to prove that this line AQ is equals to CP, right? So here we can write it, therefore AQ is equals to CP. Reason is by CPCT we already proved that the triangle in which these two sides are having, triangle number 3 and the 4th, they are congruent by side, angle, side, right? This is the side which is equals to this one, this is the angle which is equals to this one, and this is the given side which is equal, right? So these two triangles are congruent by side, angle, side. Therefore their corresponding parts, which is AQ and CP, are equal by CPCT, right? So now we are taking the last point. What is that? That prove APCQ is a parallelogram. Okay, that is our major point. We need to prove that APCQ is a parallelogram. So for that only we are doing all these things. First we prove that these two triangles are congruent. Now we prove that these two triangles are congruent, and after that we can prove that APCQ is a parallelogram. Okay, so we already proved that AP is equals to CQ. So you can write that we already proved AP is equals to CQ. We proved above because we proved that the triangle number 1 and 2, these are congruent. Therefore this AP is the component of triangle number 1 and this CQ is the component of triangle number 2. So they are equal, right? So that's why we written here proved above. Similarly we have written here that this AQ is also equals to CP, That also we proved above. Why? Because triangle number 3 is congruent to triangle number 4. So these are also their corresponding sides. Therefore, these are also equal. Here it is. Okay, so now can you tell me if the opposite sides of a quadrilateral are equal? This is equals to this one, and this AQ is equals to CP, this one. So what this figure APCQ is formed? Obviously, if the opposite pair of lines are parallel, then it is parallelogram. So here we write, therefore opposite pair of sides are equal, then quadrilateral APCQ is a parallelogram. In a quadrilateral, when the opposite pair of sides are equal, like AP is equals to CQ and AQ is equals to CP, so the particular figure which is formed is a parallelogram. Can we say that it may be rectangle? Because in rectangle also we can say that AP is equals to CQ, which is opposite side, AQ is equals to CP, that means the opposite side. So in rectangle also we can say, sir, this kind of figure is also a rectangle. Yes, obviously. So if we need to prove that these opposite sides are parallel, I mean equal also, they are also parallel. So if the opposite pair of lines are equal, then the particular figure may be parallelogram or may be rectangle. But how we identify that this figure is a parallelogram or rectangle? So listen it. In an introduction part, what I said, that a rectangle is also a kind of parallelogram, right? We have written that there is two major type of quadrilateral. First is parallelogram and the second is kite, right? Although we have written that the parallelogram is also a kind of trapezium, and in parallelogram there are some certain categories like square, rectangle, rhombus, okay, and these all are square, rectangle and rhombus. They all are the part of parallelogram. I mean they all are similar properties as parallelogram is having. Therefore the majority is in the favor of the parallelogram, that whatever the opposite sides are there, it will be parallelogram. So that means this rectangle is also a kind of parallelogram. So if it is rectangle, then also it is a parallelogram, and we need to prove only that APCQ is a parallelogram. So hence we proved it that APCQ is a parallelogram. Okay, all right. So here we don't need to prove that this is a rectangle, because in a rectangle there is certain properties also. One more, that there is each angle is 90 degrees, so that we not need to prove it. Opposite sides are equal and parallel, yeah, or you can write it that the opposite sides are equal, then it is a parallelogram. Okay, so when you need to when you prove that the opposite pair of lines are parallel, that means it is a parallelogram. So till here you have to do it that this is a parallelogram. Okay, all of you understood? Okay, take care, goodbye.